Okay, notes, inverses of functions. Inverses are things that undo each other. For example, addition undoes subtraction, and subtraction undoes addition. Same with multiplication and division. Since they're opposite functions, they undo each other. Functions can also have inverses. To find the inverse of a function, we're going to flip x and y. When we do this, we're able to find the inverse of the function, which also means that the inverse of the functions also exchange domain and ranges. So the domain of one function would be the range of its inverse function. And then the graph of an inverse function is a reflection of the original function over the y equals x line. So we can find inverses algebraically by looking at tables and graphs. So here this one says find the inverse function of f of x is equal to 2x plus 3. Notice that they gave us the table for it and they found the inverse for us. Notice that their domain, their x's of the original function, became the range of the inverse function. Same with the range of the original function became the domain of the inverse function. And when they graphed the two lines, it was a reflection over the y equals x line. That's this dotted line here. So let's look at some examples. Example 1 says, consider the function f of x is equal to 9x squared plus 1. Find f inverse x. That's what this thing right here, this f to the negative 1 of x means inverse. So what I'm going to do is I'm going to take f of x is equal to 9x squared plus 1. And instead of f of x, I'm going to write this as y. So this is y is equal to 9x squared plus 1. Since I want to find the inverse, I'm going to flip-flop x and y. So instead of y, I'm going to put x. So x is equal to 9. And instead of x squared, I'm going to put y squared plus 1. So that's the first step, is to flip-flop x and y. The second step is to solve for y. So I have to get y by itself. So I'm going to subtract 1. So I have x minus 1 is equal to 9y squared. Then I'm going to divide by 9. And I have x minus 1 divided by 9 is equal to y squared. And then I'm going to take the square root of both sides. So I am left with y is equal to the square root of x minus 1 over 9. Well, remember, instead of y, I need to write f of x. But since I already had f of x, I just found the inverse of x. So this y becomes f inverse of x is equal to the square root of x minus 1 over 9. That's my answer. Number 2 says, consider the function f of x is equal to 2 times the square root of x minus 3. Find the inverse. So I write my function, f of x is equal to 2 times the square root of x minus 3. I know f of x means y, so this is y equals 2 times the square root of x minus 3. And remember, my first step is to flip-flop x and y. So this is now x equals 2 times the square root of y minus 3. And now I have to get y by itself. So in order to do that, I'm going to first divide by 2. So I have x over 2 is equal to the square root of y minus 3. Then I'm going to square both sides to get rid of that radical. So this is now x squared over 4. I just squared both the numerator and the denominator, is equal to y minus 3. And then I'm going to add 3 to both sides. And I get x squared over 4 plus 3 is equal to y. But instead of writing y, I'm going to write the inverse of x. So this is f inverse of x is equal to x squared over 4 plus 3. That is my inverse function of the original f of x function. This next part says prove if the two functions are inverses. We know they're inverses if and only if f of g of x equals x and g of f of x equals x. Then f of x and g of x are inverses. So we have to find the compositions of both f of g of x and g of f of x. If they both are equal to x, then we found the inverses. So let's look at example 1. So remember, our goal is to do both. So we have to find f of g of x and g of f of x. And our goal is to see if they both equal x. So there's 2 steps here. Remember that this means we look at the inside function, so in this case g of x, and plug it into the outside function, f of x. So my f of x function is 3x minus 1. So I'm going to write 3, but instead of x, I'm going to put the function of g, which is x plus 1 over 3, and then finish the function, minus 1. So I took g of x, which was x plus 1 over 3, and I plugged it in to the x value of f. Now I just simplify, and if I get x, I'm good. Well, this becomes 3 times x plus 1 over 3 minus 1. The 3's cancel out, so I'm left with x plus 1 minus 1. The 1's cancel out, so I'm left with x. Good. My first one is good. That means if I do it again on the other side and I also get x, then they're inverses. So now I'm taking f of x, which is this function, and plugging it in for x for the g of x function. So I have 3x minus 1 plus 1 over 3. Instead of x, I plugged in 3x minus 1. That's why it looks a little weird here. Now I just simplify. Well, 3x minus 1 plus 1, the 1's cancel out, so I'm left with 3x over 3. The 3's cancel out, and I'm left with x. Since I have x on both of them, then I say yes, they are inverses. Happy face, we did it, good, everything works out. Now look at example 2. We got to do same thing. We have to do f of g of x and the opposite, g of f of x. So starting with this one, g of x is this right here. I'm going to plug in this anywhere I see an x on the f of x function. So I have 8 times the cube root of 2x cubed. Now I simplify. Cubed and cube root cancel out. So I'm left with 8 times the square root of 2x. Which means that is, if I multiply them together, that's the square root real quick, I'm just double checking. Yeah. The square root of 16x, which is the same as saying the square root of 16 times the square root of x. So this is 4 times the square root of x. Uh-oh. Notice this does not equal x. So because it does not equal x, I still have to check the other side, but already in my head I'm thinking they're probably not inverses. So let's check the other way. F of x into g. So my g function is cube root of 2 times x. Instead of x, I'm going to put 8x cubed because that's my function for f. So I've simplified this as the cube root I just realized I made a mistake over here. Let's pause and go back. Right here. When I canceled out the cube root and the cube, this should have been gone, which doesn't matter because even if that's gone, 8 times 2x is 16x, which is still not x. But I just wanted to make note of that. Okay, back to the other side. So this is 16x cubed. The cube, let's see. This is the same as saying the cube root of 16 and the cube root of x cubed. These can cancel out. 2 times 2 is 4. 4 times 2 is 8. I don't think we can simplify the cube root of 16. So this is just the cube root of 16x, which again is not x. So since we didn't get x for either side, like on example 1, then we would say no, they are not inverses. Last example, number 3, says determine whether f of x and g of x are inverses. Okay, so we have to do both f of g of x and g of f of x. Remember, our goal is to get x. So for this first one, we're going to take g of x, which is this function, and plug it in anywhere we see an x in f of x. So I have 3 instead of x. I'm going to put x minus 4 over 3 to the power of 3/2 to the power of 2/3 plus 4. Well, the 2/3 and the 3/2 are going to end up canceling each other out. So we just have 3 times x minus 4 over 3 plus 4. The 3's cancel each other out. So we're left with x minus 4 plus 4. The 4's cancel each other out. So we're left with x. Good sign so far. Now we're going to take f of x, so this equation, and plug it into g of x anywhere we see an x. So we have parentheses instead of x. We're going to do 3x to the 2/3 plus 4 minus 4 over 3 to the 3/2 power. So first I'm going to simplify inside the parentheses. So 3x to the 2/3 plus 4 minus 4. Well, these 4's can cancel. So I'm left with 3x to the 2/3 divided by 3 to the power of 3/2. The 3's can cancel now. So I'm left with x to the 2/3 to the power of 3/2, which cancel each other out. So I'm left with x. Again, very good. So since the composition of each of them resulted in x, then we can say yes, they are inverses.